education and research center, Navsari. Today we are going to learn eigenvalues and eigenvector. Now, what is eigenvalue and eigenvector? Now, the definition of eigenvalue and eigenvector is if capital A is n by n matrix and then a non-zero vector capital X in R raised to n is called an eigenvector of capital A. If Ax is a scalar multiple of X, then if Ax is equal to lambda X for some scalar lambda, and the lambda is called eigenvalues of capital A, and capital X is called the eigenvector of capital A corresponding to lambda. Now, Ax is equal to lambda X can be solved by Ax minus lambda X equal to 0. Now here X is common, then we can write A minus lambda. Lambda is scalar and A is a matrix. Therefore, we have to multiply the identity matrix I with lambda into X equal to 0. Now we have to solve this matrix and find the value of X. Then X is called the eigenvectors. Now we have to solve this. This is the characteristic vector. Okay. Now A minus lambda I is characteristic matrix. Now determinant A minus lambda I. This is the characteristic polynomial, and determinant A minus lambda I equal to 0. This is the characteristic equation. Now we have to solve the characteristic equation and find the value of lambda. Then this lambda is called eigenvalues. Now some notes. The most identical note, first and second, the finding the eigenvalues. Now the characteristic of 2 by 2 matrix, then lambda square minus s1 lambda plus determinant of A equal to 0. That means suppose we have to give a 2 by 2 matrix, then the characteristic equation is lambda square minus s1 lambda plus determinant of A equal to 0. Now we have to find the value of s1 and determinant of A. Put the value of s1 and determinant of A in the characteristic equation and solve this equation and find the value of lambda. And this lambda is eigenvalues. Okay. Here S1 is the sum of the diagonal element of capital A, otherwise trace of A, and this is the determinant of A. Now same is for 3 by 3 matrix. The characteristic equation of 3 by 3 matrix is lambda cube minus s1 lambda square plus s2 lambda minus determinant of equal to 0. Where S1 as it is sum of the diagonal element of capital A, otherwise trace of A. S2 is equal to sum of the minor of the diagonal element of A, and this is the determinant of A. Now note number 3. The trace of a matrix is the sum of the eigenvalues of the matrix. We have to given the matrix. That means we have to check our eigenvalues are right or wrong. Then we have to use the note number 3 and 4. Now we have to find the trace of the matrix and find the sum of the eigenvalues. If both the values are same, then our eigenvalues are right. Same as the determinant of a matrix is the product of the eigenvalues of the matrix. Now next, note number 5. A and A transpose have the same eigenvalues, but A and A transpose have not a same eigenvector. Now next, the eigenvalues of A inverse are the reciprocal of the eigenvalues of A, and A transpose have same eigenvector. That means if A has the eigenvalue lambda, that implies A inverse has the eigenvalues 1 upon lambda. Now next, note the eigenvalues of A raised to k is lambda raised to k, and A raised to k have same eigenvector. Now next, the eigenvalues of Ka is k lambda, but A and Ka have not same eigenvector. Here k is any constant, same as here k is any positive integer. Now next, same eigenvector cannot correspond to distinct eigenvalues. Now next, note the set of all solution to matrix A minus lambda I of x equal to 0 is called the eigenspace of a matrix A corresponding to lambda. Now next, the eigenvalues of upper, lower and upper lower triangular matrix and the diagonal matrix are the element of its principal diagonal. That means suppose we have to given upper triangular matrix, lower triangular matrix, otherwise diagonal matrix, then the eigenvalues are its principal diagonal element. Now the Cramer's rule. Now we have to solve 3 by 3 matrix and find the eigenvector. We have to use the Cramer's rule. Now Cramer's rule are: consider a1x plus b1y plus c1z equal to 0 and a2x plus b2y plus c2z is equal to 0. Then by Cramer's rule we have x divided by the determinant of the element b1 c1 b2 c2 b1 c1 b2 c2 is equal to minus y divided by a1 c1 a2 c2 is equal to z divided by a1 b1 a2 b2. Now examples: find the eigenvalues and eigenvector of the matrix capital A is equal to 4 2 minus 2 minus 5 3 2 minus 2 4 1. Here the given matrix is 3 by 3 matrix. Now the solution: first we have to write the characteristic equation. The characteristic equation is determinant A minus lambda I equal to 0. That means the matrix A minus lambda and the identity matrix. We have to solve A minus lambda I. That means 4 minus lambda, 2 minus 2 minus 5, 3 minus lambda, 2 minus 2 4 and 1 minus lambda, and solve this determinant, take equal to 0. Otherwise we know that the characteristic equation for 3 by 3 matrix is lambda cube minus s1 lambda square plus s2 lambda minus determinant of A equal to 0. Here s1 is equal to trace of A. That means sum of the diagonal element. H2 is equal to sum of the minor of the diagonal element. And this is determinant of A. Now first we have to find S1. S1 that means trace of A. That means sum of the diagonal element of A. And the diagonal element is 4, 3 and 1. Therefore, 4 plus 3 plus 1 is equal to 8. Now, H2. H2 is equal to sum of the minor of the diagonal element of A. Therefore, M11 plus M22 plus M33 is equal to. Now, M11 is 3, 2, 4, 1 plus determinant of M22. That means second column is cancelled out. Therefore, 4 minus 2 minus 2, 1 plus M33. That means third row and third column cancel out. Therefore, the element is 4, 2 minus 5, 3. Now we have to find the determinant of these three terms. Therefore, 3 minus 8 plus 4 minus 2 that means minus 4. That means 4 minus 4 plus 12 minus 10. That means 12 plus 10. Now 3 minus 8 is equal to minus 5. 4 minus 4 is equal to 0. 12 plus 10 is equal to 22. Therefore, H2 is equal to minus 5 plus 22 is equal to 70. H1 is equal to 8. H2 is equal to 70. Now we have to find determinant of A. Therefore, first write the matrix in determinant form. Therefore, the determinant of 4, 2, minus 2, minus 5, 3, 2, minus 2, 4, 1. Now, solve the determinant. Now we have to find determinant. Any row, any column we have to use. And answer will be same. We have to use here first row. That means 4 into 3 minus 8 minus 2 minus 5 plus 4 minus 2 into bracket minus 20 plus 6 is equal to 4 into minus 5 minus 2 into minus 1 minus 2 into minus 14. Therefore, solve this equation. 4 into minus 5 minus 2 into minus 2 minus 2 into minus 14 is equal to 10. Therefore, determinant of A is equal to 10. Now put H1, H2 and determinant of A in the equation number 1. Therefore, equation 1 becomes lambda cube minus 8 lambda square plus 17 lambda minus 10 equal to 0. Now we have to solve this equation by factorization and we have to find the factor. Here we have to given the highest order of lambda is 3. That means we get the 3 eigenvalue of this equation. Now we have to solve this equation and find the value of lambda using the factorization form. Now we have to put different value of lambda and get RHS. Like we have to put lambda like 0 plus 1 minus 1 plus 2 minus 2 plus 3 minus 3 etc. and get the RHS. Now first we have to put lambda is equal to 1. Therefore 1 minus 8 plus 17 minus 10 is equal to 0. Therefore, here lambda is equal to 1 is one eigenvalue for this equation. Now we have to find another two eigenvalues. We have to use the method. First we have to put lambda is equal to 1 and the coefficient of lambda cube, lambda square, lambda and constant. Here lambda cube the coefficient is 1, lambda square coefficient minus 8, here constant is minus 10. Now first we have to put here 0. Now addition of these two values, then 1 plus 0 is equal to 1. Now multiplication of these two values, therefore 1 into 1 is equal to 1 and put here. Now again addition of these two values, minus 8 plus 1 is equal to minus 7. Now multiplication of these two values, therefore 1 into minus 7 is equal to minus 7. Now adding these two values, 17 minus 7 is equal to 10. Now multiplication of these two values, therefore 1 into 10 is equal to 10. Now addition of these two values, minus 10 plus 10 is equal to 0. Now this is the compulsory. Here we have to get 0, compulsory. If any remainder is any value, then this value is wrong. Okay. Now here we have to get 0. Therefore lambda is equal to 1 is one eigen value. Therefore we have lambda minus 1, and the another is now cross multiple of this term. Therefore lambda square minus 7 lambda plus 10. Therefore we can write lambda minus 1 into lambda square minus 7 lambda plus 10 equal to 0. Now we have to again use the factorization form. Therefore we have to find the factor of 10 is 2 into 5. Therefore minus 2 minus 5 is equal to minus 7. Therefore lambda minus 1, lambda minus 2, lambda minus 5 equal to 0. Therefore lambda minus 1 equal to 0, comma, lambda minus 2 equal to 0, comma, lambda minus 5 equal to 0. Therefore lambda is equal to 1, lambda is equal to 2, and lambda is equal to 5. That means we have to find lambda is equal to 1, lambda is equal to 2, and lambda is equal to 3, lambda is equal to 5 are the eigen values for the characteristic equation lambda cube minus 8 lambda square plus 17 lambda minus 10 equal to 0. Therefore the eigen values of the given matrix are 1, 2, and 5. Now we have to find eigenvector corresponding the eigen values. That means we have to find 3 eigenvector for lambda is equal to 1, for lambda is equal to 2, and for lambda is equal to 5. First we have to find for lambda is equal to 1. Now we have to use the matrix A minus lambda I into x is equal to 0. Now we know that A minus lambda I, A minus lambda I is equal to 4 minus lambda 2 minus 2 minus 5, 3 minus lambda 2 minus 2, 4, 1 minus lambda. Now capital X is equal to 1 vector, column vector. We can write here x, y, z, otherwise a, b, c, otherwise whatever variables. We have to take here x1, x2, x3, and 0 we can write the column vector 0, 0, 0. Now put the value of lambda. Lambda is equal to 1. Therefore 4 minus lambda is equal to 3. 2 as it is, minus 2 as it is, minus 5 as it is, 3 minus lambda, that is 3 minus 1 is equal to 2, and 2 as it is, minus 2 as it is, 4 as it is, and 1 minus 1 is equal to 0. x1, x2, x3, and 0, 0, 0. Now we have to write the equation. Therefore the cross multiple of these two matrix, therefore first row first column is your first entry, second row first column is your second entry, third row first column is your third entry. Therefore 3x1 plus 2x2 minus 2x3 is equal to 0. Same is minus 5x1 plus 2x2 plus 2x3 equal to 0. minus 2x1 plus 4x2 plus 0x3 is equal to 0. Now, we have to use these three equations and find the value of x1, x2, x3. x1, x2, x3 that means capital X, and capital X that means eigenvector for lambda is equal to 1. Now, we have to consider first two rows. This first two equations according to Cramer's rule we get. We have to use here Cramer's rule. Therefore, we require two equations. That means we have to consider first two equations. Therefore, x1 divided by determinant of 2 minus 2 is equal to minus x2 divided by determinant of 3 minus 2 minus 5 2 is equal to x3 divided by 3 2 minus 5 2. Okay, now solve this determinant. Therefore, x1 divided by 8 is equal to minus x2 divided by minus 4 is equal to x3 divided by 16. Now, 4 is common. Therefore, this is equal to, we have to say k dash. Otherwise, we say that t, r, any constant. Therefore, x1 divided by 2 is equal to x2 divided by 1 is equal to x3 divided by 4 is equal to 4k dash. And 4k dash we again say k. Now, x1 divided by 2 is equal to k. x2 divided by 1 is equal to k. And x2 divided by 4 is equal to k. Therefore, x1 divided by 2 is equal to k. That implies x1 is equal to 2k. Then x2 divided by 1 is equal to k. That means x2 is equal to k. x2 divided by 4 is equal to k. That implies x2 is equal to 4k. Therefore, now we have to find the value of x1, x2, x3. That means put here. Therefore, capital X is equal to x1, x2, x3 is equal to 2k, k and 4k. Now k is common. Therefore, k into 2, 1, 4. Therefore, the column vector 2, 1, 4 is eigenvector for lambda is equal to 1. Now, similarly we find eigenvector for lambda is equal to 2. Therefore, write the matrix A minus lambda I x equal to 0. Now we know that A minus lambda I is equal to 4 minus lambda 2 minus 2 minus 5 3 minus lambda 2 minus 2 4 1 minus lambda. Now we have to put lambda is equal to 2. Therefore, 4 minus 2 2 minus 2 minus 5 3 minus 2 2 minus 2 4 1 minus 2. And the column matrix is x1 x2 x3 is equal to, now the column matrix of 0 is 0 0 0. Now 4 minus 2 is equal to 2. 2 is same as it is, minus 2 as it is, minus 5 as it is, 3 minus 2 is equal to 1, 2 as it is, minus 2 as it is, 4 as it is, 1 minus 2 is equal to minus 1. Now the column matrix as it is, therefore x1, x2, x3 is equal to 0 0 0. Now we have to solve by the system. Therefore we can write first row, first column. Therefore 2x1 plus 2x2 minus 2x3 equal to 0. Now minus 5x1 plus x2 minus 2x3 equal to 0. Minus 2x1 plus 4x2 minus x3 equal to 0. Now we have to find the value of x1, x2, x3. We use the Cramer's rule. Therefore, my Cramer's rule for first two equations. Therefore, x1 divided by determinant of 2 minus 2 1 2 is equal to minus x2 divided by determinant of 2 minus 2 minus 5, 2 is equal to x3 divided by the determinant 2, 2 minus 5 and 1. Now solve the determinant. Therefore, x1 divided by 6 is equal to minus x2 divided by minus 6 is equal to x3 divided by 12. Now we say t dash. Now 6 is the common. Therefore, x1 divided by 1 is equal to x2 divided by 1 is equal to x2 divided by 2 is equal to 6 t dash. And 6 t dash we can say only t. Therefore, x1 is equal to t. x1 divided by 1 is equal to t. That implies x1 is equal to t. x2 divided by 1 is equal to t. That implies x2 is equal to t. And x3 divided by 2 is equal to t. That implies x3 is equal to 2t. Therefore, x1 is equal to t, x2 is equal to t, and x3 is equal to 2t. Therefore, capital X is equal to column matrix x1, x2, x3 is equal to, now put the value of x1, x2, x3. Therefore, t, and 2t. Now, t is common. Therefore, t 1, 1, 1 is the eigenvector for lambda is equal to 2. Now, for eigenvector for lambda is equal to 5. Therefore, the matrix A minus lambda I x is equal to 0. Now, we know that A minus lambda is equal to 4 minus lambda 2 minus 2 minus 5 3 minus lambda 2 minus 2 4 1 minus lambda. Now, we have to put lambda is equal to 5. Therefore, 4 minus 5 2 minus 2 minus 5 3 minus 5 2 minus 2 4 1 minus 5. And the column matrix x1 x2 x3 is equal to the column matrix 0 0 0. Now the matrix 4 minus 5 is equal to minus 1 2 minus 2 minus 5 minus 2 3 minus 5 that means minus 2 2 minus 2 4 and 1 minus 4 is equal to 1 minus 5 is equal to minus 4. And the column matrix as it is x1 x2 x3 is equal to the column matrix 0 0 0. Now we can write the system. Therefore, minus x1 plus 2x2 minus 2x3 is equal to 0. Now minus 5x1 minus 2x2 plus 2x3 equal to 0. And the last minus 2x1 plus 4x2 minus 4x3 equal to 0. Now we have to solve these three equations and find the value of x1, x2, x3. Now we have to use by Cramer's rule. Therefore, we consider the first two equations. Therefore, x1 divided by the determinant of 2 minus 2 minus 2 2 is equal to minus x2 divided by the determinant minus 1 minus 2 minus 5 2 is equal to x3 divided by the determinant minus 1 2 minus 5 minus 2. Now solve this determinant. Therefore, x1 divided by 0 is equal to minus x2 divided by minus 12 is equal to x3 divided by 12 is equal to t dash we say. Therefore, here 12 is common. Therefore, x1 divided by 0 is equal to x2 divided by 1 is equal to x3 divided by 1 is equal to 12 t dash. And 12 t dash we can say t. Therefore, x1 divided by 0 is equal to t. That implies x1 is equal to 0. x2 divided by 1 is equal to t. That implies x2 is equal to t. And x3 divided by 1 is equal to t. That implies x3 is equal to t. Therefore, we have to find the value of x1, x2 and x3. Therefore, we put x1, x2, x3 in the column matrix. Therefore, capital X is equal to the column matrix x1, x2, x3 is equal to 0 t t. Now the t is common, therefore t into column matrix 0 1 1 is the eigenvector for lambda is equal to 5. That means we have to find the eigenvector for lambda is equal to 1, lambda is equal to 2 and lambda is equal to 3. Therefore, the column matrix 2 1 4 comma, the column matrix 1 1 2 and the column matrix 0 0 0 1 1 are the eigenvector for the given matrix capital A. Now, the next video lecture we learn algebraic and geometric multiplicity of n eigenvalues. Thank you.